let's start with a new chapter, which is set theory. So in this chapter, we'll be talking about what are sets and what are the properties of set and why are sets used, or what is the uses of sets. Now, in this chapter, it's a very easy chapter to score because the concepts are pretty much very simple. It's just that what you have to understand what is the concept, and then you have to perform simple and minute operations on them, and this chapter would be a very good point to score. Now, let's talk about sets. So what is a set? A collection of objects or items classified by a property of a rule is called a set. Or you could say a set is a collection of well-defined objects. Let's say, if I'm saying that a set of prime numbers, what do we get? We get numbers like 2, 3, 5, 7, 11, 13. It just goes on, right? Now I'm saying prime numbers which are less than 10, right? Then we'll get a set of numbers. This is how we denote a set. So whenever we are writing a set, we write it inside a curly bracket. So I'm saying the set of prime numbers which is less than 10 is equal to set 2, 3, 5 and 7, right? Now, I could use sets to define anything and everything. It's not necessary that we should define about numbers. Here we could see a set of different geometrical shapes. I could actually classify anything as a set. Like the amount of books I have is a set. The amount of stationery would be a little bit more larger set because it includes my books, pens, pencils, everything is included, right? Now, if I'm saying that the amount of people in my home is a set, right? And at the same time, I could say that the amount of people living in my locality is a set. So whatever I'm defining with a proper property, like I'm setting a rule saying that everybody who is residing in my home, so people residing in my home is the set. And if I'm saying that everybody who is residing in a locality, the people who are residing in a locality is actually a set. So it could be anything, like if I say that there are a number of chocolates in a box, so we could actually create a set based on the number of chocolates inside the box. Or otherwise, we could also create a set saying that the number of chocolates that a shop contains, right? An entire chocolate shop have this much amount of this varieties of chocolate, but still I could say that the whole as it is a set. So a well-defined objects, a collection of well-defined objects is known as sets. I hope sets and the concept of set is clear. Now let's move on to the methods of describing sets. So I told you that how do we represent sets? Sets could be represented using a curly bracket and every element. Now what are the elements of a set? So I said that there are like different prime numbers which is written here. Each one of these numbers is called the element of the set. Now, in this set where we have different geometrical shapes inside a circle, we find different elements inside the circle. Like this triangle is one element of the set. Now, this shape, this pentagon is also an element, right? So, every one of these is an element in this set, right? Now, when the methods of describing sets. So, a set can be described in two forms. So, one is the tabular form or the roster form. The roster form is like making a list of items. In math, we use the roster form to show a set which is a collection of things. These things could be numbers, letters or anything. So, what is the tabular form? The form I just showed you before, this is called the tabular form or the roster form. So, let's say I have all the alphabets of the number of the name, let's say Krishna. We have a name Krishna. Now our goal is to create a set with all the alphabets which is in the name Krishna, right? So we have K, R, I, S, H, N and A, right? So we have this alphabets and this is the collection of alphabets and it's not repeating anywhere, right? Now, let's see, we have another name. Let's take Abhishek. So we have Abhishek and here we could see that the H is repeating twice, right? So if I'm writing a set of the alphabets of the name Abhishek, we have A, B, H, I, S. Do we repeat H again? No, we won't repeat H again. Why? Because H is already listed here. So this is like saying I am asking for like ingredients to make something. And you know the salt is added in 2 times or like something is added as 2 times. Like initially you will add it and at the end too you are adding it. And once you are asking to say the recipe of the thing, repeating this one alphabet is like saying salt 2 times in recipe, right? It's just the same thing. So we won't repeat this alphabet. We'll just write this alphabet and then I, S, H is already there and E and K, right? So now let's move on to set builder form. So what is set builder form? Also, before moving to the set builder form, one more thing we have to notice here is the number of elements. So the number of elements in a set. So the number of element in a set, like if we take this set, the set of the alphabets of the name Abhishek, we have 1, 2, 3, 4, 5, 6, 7. We have 7 elements, right? So the number of elements here is 7. And in case of this name Krishna, we have 1, 2, 3, 4, 5, 6, 7. Again, we have 7 elements there, right? Now let's talk about the set builder form. The set builder form is like a rule or a recipe to make a set. So what is set builder form? Set builder form is actually a statement. It's like a rule which is made to build the set. Let's see about this set. Okay, the first set we made was of Krishna, right? So we could write it as X such that either you could use this symbol or somewhere in it's used this symbol. I prefer using this one. So let's use this. So X such that X is an alphabet of the name Krishna, right? So X such that X is an alphabet of the name Krishna is the set builder form of this set, right? So we define what is each and every element of a set by using set builder form. Now when we are talking about Abhishek, we'll just write X such that X is an alphabet of the name Abhishek, right? Now, the earlier set we were talking about, which is the set of prime numbers, right? So how do we define this set? How do we define this set? We just say that if I'm saying that the name of this set is equal to A, okay, this is set A, okay. Now, so we'll say that A is equal to X such that X is a prime number. Now, what is the set B? Let's take this as set B. So, what is set B? So, B is equal to set X such that X is a prime number which is less than 10, right? We could write it less than 10. So, these are the two forms of describing a set, which is tabular form or roster form. We just use 2 curly brackets and we just list out the elements. And we have set builder form. It's like, you know, you write what is X or what is an element, right? Now, let's move on to the next topic, different types of set. Okay, so we have different size types of finite and infinite sets. So what are finite sets? So when we are talking about finite sets, we know that here when we said that the alphabets in the name of the name Abhishek and Krishna, right? we have limited number of alphabets. We know that there are 7 elements, right? And here when we talked about prime numbers which are less than 10, we know there are how many elements are there in the set. These are called finite sets. Now when we are talking about infinite sets, right? If I'm taking a set of, prime numbers, right? No criteria, it's just prime numbers. It would go on. At the same time, if I'm taking the set of natural numbers, it will just go on till infinity, right? So these are called infinite sets too. Now let's move on about types of sets, right? The first type of set we'll be talking about is an empty set or a null set. So what is empty or null mean? It means that there is nothing inside, right? So basically a null set is where a set which have no elements inside it, like I'm naming it A, doesn't matter, they have no elements inside it. This is also called as phi. This could be named as phi. So phi is an empty or null set, right? It's like having 0 of something. So you might have a doubt that why do we have to represent a set with nothing, right? Why do we have to have a set which have nothing in it? It's just nothing only. But we know what is the importance of 0, right? Right? It's just like empty set have the equal importance as we have the importance of 0. So there's a difference in saying that I have no money at all. I have to express it, right? If I'm saying that I have 0 money with me, I have to say that I have 0 money. We need to explain that set. The set of money I have is a null set, right? Now, we represent it with a simple like curly brackets or phi. It's like having 0 of something. Just like when you have 0 rupees, it means that you don't have any money in your pocket. Similarly, the empty sets means there are no elements or items in the set, right? Now, singleton set. Empty set is basically like opening a box of chocolate and finding out there is nothing, right? Now, let's talk about singleton sets. In math, a singleton set is also a group, but it has only one special member inside, right? Now, if I'm writing what is the set of my favorite fruit, I'm just saying mango, right? So I'm just saying I have one favorite fruit and it's mango, and this set can be described as X. We could say that X such that X is my favorite fruit. Sorry, curly bracket, right? So this is a singleton set. If a set have only one element, that set is called as singleton set, right? Now we know about what are null sets or empty sets, and now we know about what is singleton sets. Now let's move on to a subset. A subset is like a special group created by picking out only those things that meet a specific condition from a bigger group. So let's say I was talking about the set of people residing in a locality, the set of people residing in a home and all, right? So if I'm taking a set of people, I am taking a set of people, I'm saying A is equal to X such that X is people residing in India, right? And I'm taking another set B where X is people residing in Delhi, right? So what does this mean? This means that set B is included in set A. How? Because the people who are residing in Delhi is also among the people who reside in India. Like it might have different states of people residing. When we are talking about India, we have different states of people residing, right? Now, when we are talking about Delhi, people who are inside India but who are specifically inside Delhi, that's the set of B. Now, we could say that B is a subset of A. So this is the form of subset. Now we say that B is a subset of A, right? How do we know that? Because A also contains B and B belongs to A. Let's take another example, right? So let's say we have a set of natural numbers. We have 1, 2, 3, 4, 5, etc. Now we have a set of even numbers. We have 2, 4, 6, 8, blah blah blah, right? Now, which belongs to which set? The set of even numbers would belong to the set of natural numbers. So we could say that B is a subset of A, right? Now, I hope the concept of subset is clear. It would be more clear when we are solving problems and you read about different questions. Now let's talk about proper subsets. A proper subset is when one set is a part of another set, but the larger set has at least one extra item than the smaller set doesn't have. Remember, all proper sets are subsets, but not all subsets are proper subsets. So here, whenever we are talking about these subsets, they both are actually proper subsets, because the bigger set have a lot of terms which are other than the terms in B or the smaller set. But if I'm saying I have a set of let's say I have a set 1, 2, 3 and 4. I'm naming the set A. Okay. Now these, let's say that 1, 2, 3 and 4 are 4 people who is reading books. Okay. Let's say 1, 2, 3 and 4, or for fun let's name 4 people. Let's do, if I don't know whether you remember the cartoon Inna Minna Minna Mo. It was a comic in Tinkle. So let's go. So A is equal to, we have 4 people here who reads. These 4 people reads. Okay. A is a set of people who reads. Now B is a set of people who dances, right? And who are in B? We have the same people who dances, right? So we could say that A is a subset of B or B is a subset of A because the same people are present in both. Now, is it a proper subset? It's not a proper subset. Why? In a proper subset, the larger sum, here there is no larger set, but in a proper subset, the larger set should contain every element in the smaller set and also additional elements from the smaller set. So, if we have a set like here, this is a very good example of proper sets, right? Proper subsets. Because why? People residing in Delhi are also included in India, but we have all other people from all other states which is remaining over, right? So this is an example of proper subsets. Now, let's talk about power sets. In mathematics, the power set of a set is a collection of all possible subsets that can be formed from the original set, including the empty set and the set itself. Let's say we have a set which is A, B, C, D. So we have a set A, B, C, D. Now, what are the subsets of A, B, C, D? We could have a set which is a null set, right? I'm taking a set of null set. Then we might have a set A alone, we have B alone, we have C alone, singleton sets are all. Now we have A and B, right? Now we have A and C, right? Then we have B and C, right? These are the 3 things we could get. AB, AC and BC is gone. Now we could have A, B, C, right? Then we could have B, C, D. Oh, we skipped D here. We have D. Here we'll have AD. We have BD. And we have CD. Right? Now, let's say BCD is there, ABC is there. We could have ABD. Right? So this just goes on, and finally we'll get into, it just goes on, and we'll also have ABCD in here, right? So This is called the power set. This is not completely the power set. If we are writing it going on, let's check this with a smaller set, so we'll get the whole concept of power set. Because this set have 4 elements, we would have to write a lot of like subsets. Let's take with 2 things. Let's take the elements A and B. So we have the first, which is null set. Then we have a singleton sets like set A, set B. Then we might have 2 people in the set A and B, right? So this is the power set of the set AB. Why? Because it includes every possible way a subset could be formed. Like how many subsets could be formed from here? 4 subsets is formed, right? Now, there is a very easy way to calculate the number of subsets a set would have. How do we calculate it? Let's see. So let's say that we have a set, say that set A is equal to X such that X is even number less than 5, or let's say less than 20. So what are we dealing with here? We have 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, I'm not including 20. So this is, the set of even numbers which is less than 20. How many elements do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to find the amount of subsets this set could produce, right? To find, there's an equation for the number of subsets. So basically the number of subsets is equal to 2 raised to number of elements in the set. So n is the number of elements. Let's see how. We had 2 elements in the set here. So 2 raised to 2 is equal to 4, and we have 1, 2, 3 and 4 subsets, right? Now here we have 9 elements. So 2 raised to 9 would be the number of subsets which is produced by this set. I hope this is clear, and then we'll talk about universal set. So what is universal set? The universal set in mathematics is a well-defined collection or a set that contains all elements or objects relevant to a particular context or problems. It represents the entire universe of items under the consideration of specific scenario. In set notation, the universal set is often denoted by the symbol U. Any other set that is discussed or defined within the context of universal set is known as the subset of the universal set. So, universal set is the ultimate power set, right? So, if we are talking about the number of kids, right, we have the universal set either with the whole number of people or whole number of kids. So, anything we talk about is included in the universal set. In the questions, universal sets are predefined. If it's not defined, we'll just take the whole entire category as the universal set. Now, we have equal and equivalent sets. So, equal sets, we say that 2 sets are equal sets when they have the same elements. Like we talked about in the earlier slide, we have 4 people here. We have the same 4 people in another set. Now A and B are equal sets, right? We could write the set if they're equal as A equal to B, right? Now, equivalent sets. Equivalent sets, we say that 2 sets are equivalent when they have the same number of elements, right? Here set A have 1, 2, 3 and set B have 3, 2, 1, right? How many elements are they having? They have 3 elements. B also have 3 elements. So they are equivalent sets. Like you don't have to have the same elements in both the sets to say that they are equivalent. The number of elements should be equal. Then we could say that both the sets are equivalent. But for 2 sets to be equal sets, you have to have the exact same elements as the set A. Now let's talk about disjoint sets. So, disjoint sets, also known as non-overlapping sets, are sets that have no elements in common. Imagine sets as group of objects. Each set contains specific objects and no object belongs to more than one set at the same time. So there is no overlap. So here is a very nice example, right? So we have a set of mangoes and we have a set of apples, right? They are a disjoint sets because we have nothing in common. Like we could, if we are considering it as a set of fruits, we might have something in common. Let's take a very different example. Okay, we have a mobile phone and we have an apple, right? Set of mobile phones and we have a set of apples. It doesn't overlap with each other. It's just disjoint, like it's not joining together. It's a disjoint set. Now, let's talk about some operations on sets. In union of sets is a very important thing in this chapter. Most of the questions comes from the area of union and intersection. So let's see what is union is. In set theory, the union of two sets A and B is a new set that contains all the unique elements from both sets. When we combine these elements, we are not repeating any item. The symbol used to represent the union operation is U. So when we write A is equal to 1, 2, 3, 4 and B is equal to 2, 3, 5, 6, right? We use the operation U. A union B is equal to, we'll write every element which is there in A and B. So we have 1, we have 2 in both of these, but we'll just write it once. We have 3 in both of these, we'll write 3. We have 4 here, we have 5 and 6 here. So this is the set of A union B, right? Now, let's see. So there is this concept called Venn diagram. Okay, so Venn diagram is not in the syllabus, but it's very necessary to know to study about intersection and union. So let's say this set, this circle contains everything in A. Okay, this is the set which is containing A and this is a set B, right? Now let's say A is something and B is something. Now we have something in common, right? Let's say we have, in the example we took here, we have 2 and 3 common in both. So we write 2 and 3 which is common. In set A we have 1, 2, 3, 4. So 1, 2, 3 and 4, right? Now in set B we have 2, 3, 5, 6. 2, 3 is here and 5, 6 is here. So what is this is A and this is B, right? A union B means this whole thing is A union B. That is 1, 2, 3, 4, 5, 6. Now, when we are moving on to the next concept, which is intersection of sets. In mathematics, the intersection of set is a fundamental operation that involves finding the common elements shared by two or more sets. You see these two elements here, these two elements 2 and 3 which is common. So that is actually A intersection B, because where are they intersecting? They are intersecting it, set it 2 and 3, right? Formally, if we have two sets A and B, the intersection of A and B denoted by A intersection B. This is the symbol of intersection. So A intersection B is a new set containing all the elements that are present in both A and B. In other words, it consists of all elements that are common to both sets. So union of sets is basically the whole set as such, like every element in A and every element in B. Now, intersection of sets is actually the elements which are both common in A and B are said to be intersection of sets. Now, complement of a set. Imagine you have a special collection of items. Let's call this collection a set. Now, the complement of a set is like the finding the opposite of the things that are not in the collection. The complement of the set contains everything that doesn't belong to that set. It looks like what's left outside the set. So, we represent, let's say we have a set of odd numbers, let's say 1, 3, 5, 7, 11, etc. right? Then we have B universal set, right? Universal set is the natural numbers, which is 1, 2, 3, 4, 5, etc. It just goes on, right? Now, we denote complement of a set by A complement, right? So what is A complement? A complement are the numbers which are not in A but in U. That is, this elements which are not there in the given set A but it is outside A. Like when making a Venn diagram, we make a box first. Okay, I was explaining the box section here, where this box is actually the universal set U, right? So here we have the universal set U, right? Now we have, let's say this is A and this part is A complement. By everything outside A is called A complement. So here A complement would be 2, 4, 6, 8, etc. So I hope the concept of complement of a set is clear. Now let's move on to the last operation, which is the difference of two sets. The difference between set A and B is denoted as A minus B. Includes all the elements that are in set A but not in set B. So we have set A and set B, right? Let's take the same example. Set A is equal to 1, 3, 5, 7, 11, 13 till 15 we could take, right? Set B is equal to, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? I'm saying this is B. Now, if we are finding set A minus set B, right? If we are denoting set A minus set B, we'll subtract all the elements which are in A and B as common. Like we are subtracting B from A. So 1 is there in B, 1 is there in A. So this gets 0, 3 and 3, 5 and 5, 7 and 7, 11 and 11, 13 and 13, and the answer would be a null set because every element in A is there in B. Now, if we are taking the opposite, which is set B minus set A, we have set B minus set A. So, we'll subtract set A from this. That is, we subtract 1, 3, 5, 7, 11 and 13. These are prime numbers, right? 1, 3, 5, 7, 11, 13. We'll be left out with 2, 4, 6, 8, 9, 10 and 12. So this is the difference of two sets. I hope it's clear. Now let's just quickly go through what all we talked about today about set theory. We talked about what a set is a defined collection of objects. Then we talked about the two methods to describe sets, which is the tabular form or the roster form and the set builder form. Then we talked about empty or null set and singleton set. Then we talked about subsets or proper subsets, power set and universal set. We talked about equal and equivalent sets and then disjoint sets. We also went into some operations like union of sets, intersection of sets, complement of a set and difference of two sets. I hope this chapter is very clear to you.